Hi guys, so we're going to look at our next conic section today, which is an ellipse. So we're going to be using this part of the foldable talks about ellipses. And what's written on here is the standard equation for an ellipse. Now, before we get started looking at this, I want to show you guys a couple models that kind of explain how ellipses are formed. So first, your actual definition of an ellipse is all of the points when you have 2 points on your graph. Okay, so these 2 points that are marked here, each one of those points is called a focus. Okay, together, when you have more than one of them, they are called foci. All right, so what happens for an ellipse is if I take a certain point that is a distance, here's one distance and here's another distance. If I add those two distances together, it's going to be consistent for this entire, all of the points that are on this ellipse. So to show you guys what this is going to look like, if you look up here at the top, it tells you the two distances. Okay, right now one of these distances is 2.1, the other distance is 3.5. They add up to 5.7. It's going to stay adding up to 5.7 as this moves around. So I'm going to go ahead and play this. Okay, so there it goes. And if you guys see, again, it's the sum of those two things is always 5.7. So it's always 5.7, always 5.7. All right. It doesn't matter what the distance of the string is. We can move it farther away. Okay, so my string's farther away now. It's still going to form an ellipse, even though they add up to a bigger number. Or I can move that string closer if I wanted to. All right, and those 2 points, each one is called a focus. Two of them together are called foci. Now I want to show you guys a couple other things. All right, this is a little video that's going to show the same thing, so you can see that that distance, again, they add up to the same amount. So those two toothpicks represent your foci, and it's going to put the string in between the two of them. And then the amount, as you guys can see, the amount that's away from it, that has to add up to the same amount each time. So it's going to take the pen, and then it's going to move to different places around that foci. And that's how we get our ellipse. All right, so now let's go ahead and look back at our notes. And let's look at the standard form. Oops, this is the wrong one. Sorry, guys. Standard form of an ellipse. Okay, so on my equation, the two equations we're going to look at, there's actually two different ones here. The first equation is going to create a horizontal ellipse. The second equation is going to make a vertical ellipse. The reason for that is if you notice it says that A is always greater than B. And those values are always greater than 0. We're not going to look at negative values. Okay, so since A is greater than B, that means that on this first one, what's under X is a larger number, and it's larger side to side. On the second one, what's under Y is a larger number, so it's bigger up and down. All right. On this equation, your center, okay, the center is HK. Okay, HK is your center, just like it has been for your circle, and like it's going to continue to be for the rest of our conics. So HK is the center here, and notice H is with the X and Y is with the K value. Also notice this equation is equal to 1. That is going to be something that's consistent in these equations, and that whenever we write it in standard form, we need to make sure that that's true. All right, so what these other values mean, A and B, okay? A is the distance if it's under the X, okay? So let's look at this first one. When A is under the X, it's the distance I move from the center out to the side here. So that distance is A. B, since it's under the Y, is the distance I move from the center up to the top. So that distance is B. Okay? Now, since the A distance is bigger, okay, that point that's outside of it, all right, that's going to be our vertex. The B, well, the one where B touches, since it's not the bigger point, It's still a good point for what we need for our graph. We call that the Co Vertex. Okay, that's called the Co Vertex. And there's two of them. So you'd have another vertex over here and another Co Vertex over here. Now the distance all the way from one vertex to another, so 2a basically, that value, 2a would be the major axis. Okay, the length of the major axis, because it's the longer one. 2b would be the length of the minor axis. All right, 2b would be the length of the minor axis. So b is, again, a and b are just how far from the center I move to the vertex. The whole axis is double that length. Now what these also have is what we just saw. Ellipses are based off of those foci, okay, or one of each focus. So I'm going to make two little green dots on the inside here. Those 2 points are my foci, okay? If you notice, they have the same horizontal spot, they're of the same y value as my center, okay? To find what these values are, this is where we're going to use a new letter called C. C is the distance from the focus to the center. That's my C value. All right? So to find the C value, we're going to use this equation that's written up there at the top. Now you can rearrange that equation if you want to. You can rearrange that to b squared plus c squared is equal to a squared, or you could rearrange that as c squared is equal to a squared minus b squared. There's lots of different ways you can write that equation. But that's how we use to find that c value. To find the location of the focus, what we would do here, if you notice, it has the same y coordinate as the center. The x coordinate, though, is different by the distance of c. So what we do is we take the x coordinate, which is h, and we add and we subtract c. Then the k coordinate stays the same. So that's how I find my focus. Now where this is going to be different is when we look at these vertical ones, okay? So on the vertical, our vertex, okay, again, our a value now, what's bigger is vertical. So my vertex now are the points up and down. That's now the vertex. Which means A, and again, you don't have to worry too much about the A, where the A and the B is. Just notice if the larger number, okay, A is the larger number. So if the larger number is below the Y, it's bigger up and down. So there's my A. So my major axis now is this vertical axis. My minor axis now, okay, there's my B value. There's my co-vertex. All right, so that's the difference here. The shorter distance is now side to side. Now the focus is always on the major axis. So for this one, my focus would be here. So I'll still use C to find the focus, but this time I'm going to keep the same x coordinate because it's in line with the center. The x's is the same, but I'm going to take K and add and subtract C. And that's how I'll find the focus for this one. Okay, so it looks a little bit different. Now, what I want you guys to see, this is, all of these little examples I'm showing you guys are available online if you want to look at them. I'm going to show you guys another little way that you can kind of move around with some of these variables to see what happens. So let's look at our notes page on our website. So if you go here, you'll see this is a link to that first one we looked at with a pencil. Then over here with student.desmos, with that course code, that's going to take you to this activity. Okay? And this is one that you can play around with if you want to see what happens when you change these variables. So I'm just going to show you guys a couple things on here. All right, this is our standard form of our equation. So let's see what happens when we move the A and the B. As A gets bigger, notice that the major axis is getting bigger. Okay, those points in red are the vertices. That red dotted line is the major axis. As B gets bigger, now look what happens when B is greater than A. Now it's vertical. Now the major axis is green, and the vertices are the orange dots. Okay, so when B is bigger, when the value, again, think about B being the number below the Y in this case. So when the number under the Y is bigger, it's vertical. All right, and you can also see how that relates to those points. We also can move H and K, which is going to move our center. Okay. And then just gives you, again, that same information that we just said. So if you want to play around this a little bit on your own, you're welcome to. It gives you the information on how to get there. Let's also look at the focus here. Okay, so if this is a horizontal ellipse, my A value here I need to keep bigger than my B just because of the way I set this equation up. Okay, so I set this up where A is under X. So let's keep A bigger. So as I change B, it changes the location of the focus. And you guys can see it's getting closer to the edge there almost as those points are further away from each other. Then as they get closer, there's a little bit more space. So let's try something like this. And you can see that focus getting closer to the center. All right, now we're going to switch it to where my bigger number is going to be under the Y. Okay, so my bigger number is under the Y. Again, we talked about this. And then look at where it makes your focus appear. And again, with this, if you want, you can move your center. This is something you guys can play around with if you want to get some more visual examples of these ellipses. And you can find both of those links on our website. All right, so let's go back and let's do an actual example here. Okay, what we're going to do is we're going to start by writing this equation in standard form. So if you notice, in standard form, this is always equal to 1. So first I'm going to move that 81 to the other side. So I'm going to make that, let me just rewrite it on top to save a little bit of space. So it was minus 81, so now this is going to equal 81. And what I'm going to do to make this equal to 1 is I'm going to divide everything by 81. So now I have x minus 2 squared over 81 plus, and I can simplify this, that becomes y plus 4 squared over 9 now, because 9 over 81 simplifies to 1 over 9. And it's all equal to 1. Now it's in standard form. So let's go ahead and draw the graph first. That's a little bit simpler. First thing I need to do when I draw my graph is I need to find my center. Okay, so let's find our center. That's going to be at 2, negative 4. So the x-coordinate here is 2. And down to negative 4. Okay, then I'm going to figure out where my vertices are. So my vertices, the 81 is bigger, so this is going to be bigger horizontally. That means that A value is 9. Okay, so from the center, I'm going to move out a distance of 9. So that would put me out at 11. And then backwards it would put me at negative 7, because I'm moving 9 away from the center. And there's the two vertices. Now let's do the co vertices. Okay, so the smaller number here is 3. 3 is my B value. So I'm going to go up 3, and I'm going to go down 3, and that gives me my other co-vertice. And then to draw the graph, just connect your dots, and there's your ellipse. Well, it doesn't look too much like an ellipse, but that's what your ellipse would be. Okay, again, this is wider horizontally because the value of the x was bigger. The last thing we're going to do is we're going to find the value of the focus, okay, or the foci. So in order to find these values, we need to know what C is. Okay, so we're going to use that equation we have up there. We know that C squared is equal to A squared minus B squared. A squared, this is nice because it's already squared for us. The bigger number here is 81. The smaller number here is 9, which means that C squared is 72. So C is the square root of 72. And we can simplify that to 6 root 2. So then to write the coordinates of the foci, we need to think about where they're going to be located. Since this is wider horizontally, they're going to be on the major axis, okay, which means the x-coordinate is moving away from the center. The y-coordinate is the same. So I take the x-coordinate of the center, which is 2. I add or subtract C, and then the y-coordinate stays the same, and my y-coordinate is negative 4. So those are the coordinates of my foci. All right, we're almost done. This one's a little bit longer, guys. Sorry, because there's a lot of new vocab here for you guys to learn. So we're going to go ahead and we're going to write the equation of an ellipse. All right. So it tells us the major axis is 8, And the foci are at 0, 2, 0, negative 2. Now it helps to draw a picture here, okay? My focus, or foci, both of them, are at 0, 2, and 0, negative 2. The center is always in the middle, okay? The center is always in the middle of those. It's in the middle of your vertices, and it's in the middle of the foci, okay? So that tells us it's pretty easy to find our center now. Halfway between those 2 points is 0, 0. Okay, so we know our center. It says the major axis is 8. Since the foci are going vertical from the center, we know that the major axis is going to be up and down because the foci are always on the major axis. If the total distance is 8, then that means the distance from the center to one endpoint is going to be a distance of 4 because that gives me a total major axis of 8. All right, so we've already had part of our equation figured out, so now we just need to find how far we're moving horizontally. So in order to do that, we're going to use that same equation we've been using. We're trying to find b, okay? We're trying to find b. So b squared is equal to a squared minus c squared. So what we know here, we know a, okay, is the distance from the center, okay, to the end point. A is a distance of 4. So 4 squared is 16. C is a distance to that foci. So that distance is 2. We square it, that's 4. That means that b squared is equal to 12. And we're going to go ahead and leave it as b squared, okay? Because even though if we want to have this picture drawn perfectly, we'd have to take the square root of 12. But again, we're trying to write the equation here. So to write the equation, we know our center is at 0. So that means I'm going to have x squared plus y squared. It's going to equal 1. It's bigger vertically, so the a value goes below the y. That's going to be 16. And then I'm going to have 12 under x. All right, last one's just going to be writing the equation from the graph. Actually, probably a little bit simpler for you guys than what we just did. We just need to make sure we can find the center here. So it gives us 2 vertices. We know that the center is going to have the same x-coordinate as the point above it, and it's going to have the same y-coordinate as the point next to it. So that's my center. So I can go ahead and start my equation. It's going to be x plus 3. Remember, it's always the opposite sign, just like circles. Y plus 1.5. All right. Then to find that distance, let's look side to side. Okay, side to side, how far did I move to get from the center to the co-vertex? I went from negative 3 to 1. That's a distance of 2. 2 squared is 4. Then let's look vertically. Vertically, I went a distance from negative 1.5 up to 2. So I moved a distance of 3.5. So I would go ahead and do 3.5 squared, which is 12.25. If you want to leave it as 3.5 squared, that's fine as well. And this whole thing is equal to 1. And there's your equation. Alright guys, so that's it for ellipse. Just remember, if you want to play around with some of those little visual things we looked at, you can find links to those under notes on our Weebly site.